Today we are going to learn about the intersection of circles. The National 5 essential skills are substitution and Pythagoras. Intersection of two circles. There can be three different scenarios. Circles that don't intersect, circles that touch at one point, and also 2 points of intersection. It is not possible to find the points of intersection by substituting one circle equation into another, like we did with a straight line and a circle. However, what we need to consider is the length of the radius of each circle and the distance between the centres. Example 1. Circles that do not meet. So the first thing we need to do is find the distance between the two centres. To do this, we first of all need to find the centre of each circle using the formula from the exam sheet. And we also need to use the distance formula you learned in the straight line topic. So the distance formula is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. Remember, this is not given in the exam and must be committed to memory. Once we've got the distance between the centres, we then need to find the total of both of the radiuses. To find the radius of each circle using the exam formula sheet, we would then add them together, and then final step is to compare both of our answers. If the distance A to B is greater than R1 plus R2, then the circles do not touch and there is no point of contact. Example 2, if circles touch at one point, again we start with finding the distance between the two centres. We would find the centre of each circle and then sub this into the distance formula, again that we learned from the straight line topic. From there, again we need to find the length of each radius in each of the circles and add it together. And then comparing our answers. So if the distance A to B is equal to R1 plus R2, that means the circles touch at one point. Example 3. Circles that touch at 2 points. So starting again with the distance between the centres, we find the centres of the circles and sub them in. Once we've got the distance between the centres, we look at each radius and add them together. And finally comparing our answers. So if the distance A to B is less than the R1 plus R2, then the circles intersect and have 2 points of contact. Example 4. Circle 1 has equation x plus 2 all squared plus y plus 1 all squared equals 8, and circle 2 has equation x squared plus y squared minus 8x minus 10y plus 8 equals 0. Determine how many points of intersection the two circles have. So first of all, let's look at circle 1, its centre and its radius. So looking at the general form of the equation of the circle, x minus a all squared plus y minus b all squared equals r squared, and we'll compare that to the one we've been given. We'll compare our coefficients. So negative a is equal to 2, meaning that a is minus 2. Negative b is equal to 1, therefore b is negative 1. And r squared is 8, meaning r is root 8. Therefore, the centre of this circle is negative 2, negative 1, and it has a radius root 8. Looking at circle 2, again we'll write down the general form of the equation of a circle, and this time we're comparing coefficients to obtain g and f. So 2g is equal to negative 8, therefore g is minus 4. 2f equals minus 10, therefore f is minus 5, and c is equal to 8. Firstly, looking at our radius is g squared plus f squared minus c, so negative 4 squared plus negative 5 squared minus 8. will give an answer of root 33. Then our centre is negative g, negative f, therefore circle 2 has a centre of 4, 5. Now we need to find the distance between the two centres, and we need to find the total of both radius. So if we look at the distance between the centres, C1 has a centre negative 2, negative 1, and C2 has a centre 4, 5. So using our distance formula, if we do y2 minus y1 plus x2 minus x1, we get 5 minus minus 1 all squared plus 4 minus minus 2 all squared, and we need to take the square root of this. So we'll give 6 squared plus 6 squared, which is the square root of 72. This can be simplified down to 8.49. Probably best to change this to a decimal in order to compare when we add our radius together. So now looking at our radius, r1 plus r2 will be root 33 plus root 8. Adding these together, we're going to have an answer of 8.57. Therefore, as our distance, 8.49, is less than our radius, r1 plus r2 added together, of 8.57, this means that the circles have 2 points of intersection. Visually, this is what it would look like. So our distance between the centres is less than r1 plus r2, and they overlap. Now try this example on your own. Please pause the video. And the solutions for circle 1, the centre is negative 2, 1, and the radius is root 10. For circle 2, the centre is 10 root 3, and the radius is root 90, which simplifies to 3 root 10. And then if we do the distance between our two centres, C1 and C2, we get an answer of root 160, and this will simplify down to 4 root 10. So as the distance between the centres is exactly equal to r1 plus r2, 4 root 10 is equal to root 10 plus 3 root 10, the circles touch externally at one point. And here we can see a diagram that illustrates this. So what have we learned today? Today we've looked at the intersection of circles. There are 3 conditions for this. If the distance A to B is greater than r1 plus r2, then the circles do not touch. If the distance A to B is equal to r1 plus r2, then the circles touch at one point. And if the distance A to B is less than r1 plus r2, then the circles intersect and have 2 points of contact.